Hello student, my name is Hitesh and you are watching my channel, Your Classroom at Home. If you really want to increase your mathematics skills, so please don't forget to subscribe my channel. Student, in today's lecture, I am going to solve a special type of linear inequalities. Let's watch it. X minus 2 upon x plus 5 is greater than or equals to 2. The question arises whether we can apply cross multiplication here. Of course not, since we don't know whether this number is positive or negative. If this number is positive, there is no problem for cross multiplication. If this number is negative, by applying cross multiplication, the answer becomes wrong. We can understand these things by taking an example. Suppose 3 upon minus 4 is less than 2. Every negative number is always smaller than positive number. Now cross multiply these two numbers. 3 is less than minus 4 into 2. 3 is less than minus 8. Is this real true? Of course not. Minus 8 cannot be greater than 3. Hence, we cannot apply cross multiplication here since we don't know whether x plus 5 is negative or positive. So, what will be our strategy to solve this kind of question? We will transpose 2 to the left hand side. X minus 2 upon x plus 5 transpose 2 to the left hand side. Minus 2 is greater than or equals to 0. By taking LCM, x plus 5, x minus 2 into x plus 5 is greater than or equals to 0. X minus 2 minus 2x minus plus minus 5 to the 10 upon x plus 5 is greater than equals to 0. Plus x minus 2x minus x minus 2 minus 10 minus 12. X plus 5 is greater than or equals to 0. Taking minus 1 common here, minus x plus 12 upon x plus 5 is greater than or equals to 0. Now here we see that there is minus sign. So we have to multiply both sides by minus 1 to make this part positive. Whenever we multiply both sides of inequality with the same negative number, the sign of the inequality will be reversed. So we can say after multiplying minus 1 on both sides, x plus 12 upon x plus 5, this sign will be reversed. It means less than or equals to 0. Now applying wavy curve method to find the solution set of given inequality. First of all, we will draw a number line. The critical point for this factor is minus 12. After equating with the 0, we can obtain the critical point. Here the critical point is minus 5. Let's say this is minus 12 and let's say this is minus 5. To the right side of minus 5, there will be always positive sign. Both factors have odd powers, so in other region the sign will be alternatively negative and positive. So if this sign is positive, this will be negative. If this is negative, this will be positive. Now our requirement is left hand side of this inequality is less than 0. It means this interval is a solution of given inequality. Now student, we have to check these two critical points also. If x equals to minus 12 plus 12 makes the numerator 0. It means left hand side will equals to 0. Here the sign of the equality has been given to us. So x will equals to minus 12. Now take x equals to minus 5 and put this value of x in given inequality, minus 5 plus 5, make the denominator 0. Denominator cannot be 0. Therefore, we can say x cannot be minus 5. So the solution set of given inequality is x belongs to minus 12 to minus 5. Minus 12 is enclosed in closed bracket and minus 5 is enclosed in open bracket. Since minus 5 is not the solution of given inequality, but minus 12 is the solution of given inequality, and all the points between minus 12 and minus 5 are the solution of given inequality. We can represent this solution set on number line as draw a number line. Let's say this point is minus 12, and let's say this point is minus 5. Minus 12 is the solution of given inequality, so we will draw the circle for minus 12. Minus 5 is not the solution of given inequality, so we will draw a hollow circle here and draw this portion of number line, which means these are the solution of given inequality. So student, we can make working rule to solve this kind of linear inequalities. If this kind of linear inequalities has been given to us as ax plus b upon cx plus d is greater than a, or ax plus b upon cx plus d is smaller than k, or ax plus b upon cx plus d is greater than or equals to k, or ax plus b upon cx plus d is smaller than or equals to k. Suppose this kind of linear inequalities has been given to us, then we can solve this type of the linear inequalities by using this algorithm. Step number 1. Transpose the constant term to the left hand side. Step number 2. Simplify the left hand side of inequality. Step number 3. Find the critical points by equating each factor in numerator as well as in denominator. with 0. Find the critical points by equating each factor in numerator as well as in denominator with 0. Now, plot these critical points on number line. Step number 4. Mark positive sign to the right side of greatest critical point. Another reason mark alternatively negative and positive sign. Step number 5. Select appropriate reason on the basis of inequality obtained in step 2. So student, this is your homework to find the solution set of given inequality. Find the solution set of following inequality. X plus 3 upon x minus 2 is less than or equals to 2. Question number 2. 2x plus 4 upon x minus 1 is greater than or equals to 5. The answer of these questions are here x belongs to minus infinity to 2 union 7 to infinity. And the answer of this question is x belongs to 1 to 3 close interval. After finding the solution of these two questions, you can match your answer with these answers. So student, we can solve these kind of linear inequalities with the help of this algorithm. So keep watching my videos and keep practicing. Thank you. Take care.